Hello, if you're nice to see again, I'm Chris. In the last video, I showed you how to use the Pilz EF EtherCAT FSoE to configure FSoE master and to make some FSoE connections with other FSoE slave. In this time, we do it in opposite way. We will configure EL6910 as a EtherCAT as a boost FSoE master, and then to make this FSoE connections with the EF EtherCAT FSoE Slave. So this time, this Pilz module will be FSoE Slave. So not a big deal, just like this conversions. Let's start. Before I continue to my video, let me introduce myself again. I'm Chris. I come from Hong Kong. Now I'm working some stuff with factory automations. In the left hand side, you can find my blog, my YouTube channel, and my Twitter. If you like my video or something, you can follow these items. So let me go through again this conversion. And here you have by using EF EtherCAT FSoE, you have two engineered tubes. The one engineered tubes is allow you to configure the EtherCAT master. In this case, I'm using Beckhoff TwinCAFE, but you can use Codis or anything you want. And you also have a tubes called PNOZ multiple converters to configure this module, the FSoE master and slave connections. Here is the screen to configure the FSoE slave in Pilz. It's not so different between to configure the master. So you just need to make sure that you set up the FSoE address and to match it in the TwinCAT side. And also don't forget to download the ESI file of Pilz module. You can download this file from their websites, and please move this file to the C TwinCAT 3.1 config IO EtherCAT. Okay, for the introduction, I think it's enough. Now we can turn the camera to see actually to go for again the hardware that we are using in this tutorial. Okay, now here is the hardware that we are using this time. So it's very similar to last tutorial. You have a PC that with a TwinCAT runtime installed. For this green cable, it is I config this Ethernet driver as a real-time driver. Then you're connecting to the input port of the EtherCAT controller, and the output port of the EtherCAT controller will connect to the Pilz module's input, and for the output you connect the white mirror. So this time the EL6910 is the main characters. You make FSoE connections to our Pilz module this time. The conversion is very similar to the last tutorial, so I think the introduction here is enough. Now we can start to configure our project. So we will configure the Pilz side first. Now I latch the PNOZ technology converter software. We can start to configure the FSoE slave conversions. So in the left hand side, you can see this FSoE master conversion tab. Then here you can find the slave conversion tab. So click here. Now you can configure 4 slots in here. As I mentioned before in the last tutorial, that there is a maximum 4 FSoE slave connections allowed you to configure in this module. What you need to do is very easy. In the right hand side, you can see the live module in here is 8 boot-in slot. Let's drop it in the slot 61 to 64. Great, done. And then just make sure that you need to configure the FSoE address. And also, as I mentioned in the last slide before that, for this module, you don't have any additional parameters that config for this 4 slot. So just configure 61, configure the FSoE address, and here 63, and here is 64. Okay, so let's save it and then check address is config is okay, no problem. So we can go to config our program. So here is the program that we configured last time. And this time so we will add some FSoE slave connections here. Let's go right click, activate, go to IOS, and now you can see that 61, 62, 63, 64. This one is the FSoE address, so it's the slot number. So you choose 61 first, and then we will use the first output. Here you can see here, and then we activate one more. Go to here to choose 61, and the second, I mean 62 is better, so choose 62, and that's the first output. Great. Then now we can drop to the input, drop the status. So in the first one, I would like to use this as the status, my status, so my indication is stop. And for the, oops, okay, I need to drop it. I need to drop it. Great. In the other one, I would like to drop it to the input channel of my white mirror modules. So now it's finished. And then I would like to feedback the signal. So I activate, go to here, and I will use 61. I think 61 is better. The second bit. If this second bit is turned on, then I will just feedback the FSoE signal back to our Pilz module. I think it's 61. I think now you can only use this second one. Great, and you can just drop it. Okay, done. Then we can save it to make sure no error. Great, we can download it. We can go online. Then we can go to Pilz and go to Project Manager. Then you need to enter the order number and the serial number. And here is the serial information depends on your real hardware. Then it's some time to receive the information from the device. Then you can just download. Then to save the project in the user's memory and activate it. You spend around 30 seconds something because this is not a very big project in my side. Okay, so please restart the Pilz module. Great, now it's restarting. Done. Okay. Now the Pilz is finished. It's very easy, right? Now it's the time to start to configure in the trinket side. Okay, now we start to configure the trinket side. So we start the trinket project. So the first one we need to add the EtherCAT master in our project. So what we need to do is go to iOS device, add new items, and then choose EtherCAT master. So EtherCAT master is added in your project. Go to right click it, and then go to search button. So choose the real-time Ethernet driver that you use in your project, and then we can press use the scan functions to scan all the nodes that inside our project. Okay, so press yes, just for a second. Then I would like to mention that it's not all the nodes can be found in by using these functions, and also even if some nodes that you can find in your project are found in the network, but if you don't have the ESI file, that some data or some parameters you may not config. Yeah, so it's just make sure that you install all the ESI file in your trinket, in your Windows elements. It's very important. So I think it's time finish. Great. Okay. Done. Now all the EtherCAT slave is scanned in our project. The first I'll show you is the Pilz modules. Why? Because when I open it, you see the 4 modules automatic insert in your system. It's 61, 62, 63, and 64. This is the 64 slots that we install in the previous configurations for the config 4 for FSoE Slave. If you don't have you cannot scan, you need to configure by one by one. You can go to here, you can go to this way and go to slots, and then you can go to drop down. Then you can this for group a group that for empty slot allow you to configure it manually. So but this time, because we have the real hardware in our side, so we don't need to configure it by manually. Great. Okay, so we configure all our EtherCAT scan all our EtherCAT slave. The next one, you can add our PLC project. Go PLC, right click, add new items, and start the PLC project. Okay, then the next one, I will save it and go to GVLs. I'll add a GVL. This, and the name is, for example, safety. So I just define two variables that I'll use in here. The first one is error arc. It should be %q star mark boot type, and I'll have a run. It also is the add %q is also a boot type. Great. Okay, then we can build it first one time, and then we can go to configure our safety project first. So safety, right click, add new items. You can choose your 3 items. This time I'll use this one, trinket safety project config inputs. Because it's very convenient, they have a template that automatically add these 2 items and linked to the project. You don't need to do so much thing here, so I choose this project. That's okay. Okay, so a trinket project is installed in your trinket project. The first one, I would like to configure my target system. So go to target system, and this time I'm using 6910, and I click the plus button, choose the which 6910 I'm using, and then great, you can see. Okay, oops, sorry, close it. You can see that the firmware version and the FS address automatically upload from terminal to your project. Then the next step is we can start to configure the EtherCAT slave. So how to do this? So in the default, there's one trinket safe group, and I'll add a folder, because if your networks become bigger, so it's better to have a folder to manage your network. So I call it FSoE Slave Pilz, and then I right click, add new items. So this time I'm use safety, EtherCAT. I'll choose this one, equal in and equal out, edit, and then a FSoE slave slot is added in your system. The next step is I will make a beautiful name to this module. I got Pilz FSoE Slave 61. So great, you done it. Let's copy name. I just prefer to edit one by one. So 62, and then I'll have a 63, and then I'll have a 64, and then I'll just 62, and then this one is 63, and then this one will be 64. Done. Okay, so the next step, we can open it, and then we set config the FSoE address, and then press this, use this plus button to link to the physical device. So right click it, so choose 61 in here, and then save it. You automatically config all the stuff. Let's do the same thing here. So this is 62, plus button, choose I think this 62, right? I think it's very small, I cannot see it. I think it's 62. Yeah, 62, okay. And here 63, press button, and then 63. Save it. Great. And here 64, and then choose 6. Oops, lengthening. Go to 64 in here. Save it. 6. Done. You config all the slots. Just make sure. Check it again. Double check. 61, 62, 63, and 64. Great. All these is config. Now we can add a GVA safety global variable list. So here, right click, add a list in here. So you use 6 variables in here. So 1, 2, 3, 4, 5, 6. Okay, and then now we name all the variables. Slave 61, and in 0, and I have slave 61 out 0. I have a slave 62 in 0. I have a slave 63 in 0. I have a slave 64 in 0. And then finally I will define the output again, slave 64 out 0. Great, then we can use the assignment to assign this variable as the input. Right click here. This is your project name. So this is my safety group. I use align system 61 maybe to safety input 0. Then do the same one for the input. So what's this one? It will be a 62 in 0, right? So go to here, 62 and in 0. And do the same thing here. We can use filter, but I'll directly show you one by one how to find all these slots. You can use search button in search field in here to filter the alignment device you would like to use. But I will, in this case, I will just config it hand by hand. 64 in 0. Great. And then you have 2 usage. It means you config the output. So do the same thing here. Output 61. Then config as output. And here is 62. I think it's 64 or 0. Great. Okay, let's save it. Now we can config some simple safety program here. Because let me close it and close it. Okay, so because n here just create some simple logic to check our connection is work or not. So I'll just use a n in here, safety n block in here, and right click to change name. Then we can use the data the variables we configured before. So it should be 61 in 0. Okay. Then saving this one 62 in 0. And go to configure output. Oops, not here. Change. So in here it should be 61 and 0. Okay, great. Oops, I think I forgot something. Great, and then we can add a new network. Okay, and then add a new network in here. Then drop it all block in here. Then configure it as 63 0. And here 64 0. Great. Oops, sorry. Here. Okay, so for the output, just do the same stuff. Great. Okay, so save it to make sure no error. Done. Then we can go back to the normal program because there's some paths for us to, because we don't have not just have the FSoE slave connections. In the Pilz we also have the FSoE master connecting to other safety slave. So we need to make the loopback program again. And all this stuff is I explained in the last tutorial. So I will just make very fast, not explain too much. And here, So I have edit FSoE structures, and then just copy it. Okay, copy it, and then I will define a GVLs. Oops, sorry, and then GVLs go Pilz, and then sorry, I just copy some stuff in here in my last tutorial. Okay, then I'll have a block of IOs. Oops, sorry, and I need to make it a bit more IOs. It should be same and just okay, just same and great. Okay, and then okay, done. Save IOs and Pilz and safety. Okay, and then I will make a loop in program in here. If you don't know, what I'm doing, then you can go to my last video to see. I have very clearly explained that what I'm doing here. So and then finally you can just build it to make sure no error. Okay, great. And then and also we can build a safety project. Choose a safety project. Press the check button. Great, also no error in the safety side. Then we can start to map all the data. So for this process, it's only just for the Pilz safety master. So if you don't want to see this, you can just skip this part and go to the last 5 or 6 minutes to see the result. Okay, so open my, I think here, 1, 2, 3, oops, sorry, 4, okay, and right click, 1, just map all this data one by one. 2, let me show again. This is for the master setting, FSoE master setting of Pilz. So it's not a must step if you just use Pilz as a FSoE slave. Great. Okay, and then oops, and then make sure don't forget to map the EtherCAT non-safety data. And here is the output. Change output. Great. And then we can map each EtherCAT slave by here. So I have a slave in here, and then I have a slave in my couplers. So I think it's here. I have a 1904. I have 2 more 1904 in where? I think in here. Yes. 1 more 1904. And then I have 12904, I think. Great. Okay, I can just map this also. Great. 1. 1, and I have here this one, right? Yes, 2, and this one is also 2, and I have 3, and then I have 4. Okay, great. Mapping is done. So what we need to do, we can just download our project. It's to download the Lomo program and change to run mode again, and then to log in, press the pay button. Okay, so it works. And then we can need to download the safety project. So we go to here, Oh, sorry, let me go to in here. Yeah, let's select the project. You can download the project to the save terminal. So go to plus this button, and then you can enter the username. In my case, it is default is administrators. Or the serial number is 1198182, and for the password it should be train safe in default. Train safe. Next. Okay, just put the checkbox again. Next, enter your safety password. I hope it's not error. Okay, great, done. Okay, so we can save it. So we can go to check our system now. How to do this? The first thing, we need to open two windows. I will open this one, and I will drop this group to here. Great. Then I open this safety, and then I'll click select the screen, then press the glass icon. Now you see the input actually is, you can see input is turning on, but I will turn run mode. Oops. Okay. So I need to reset it first. I need to then turn to run mode. Okay, just wait a second. Let me see what happened here. So I think I make a mistake. I forgot to map the reset signal and the run signal. Sorry. And go to here. Just press this button and select error ACK. And here select run. Great. Save again. And download. I need to download my safety project again. So for the username is administrators 1198192. The password is train safe. Okay, select the entire project status, and next, and yes, and enter my password again. Great. Okay, I think this time it should work. Let me check again. And okay, just cancel this run button, and then plus the class mark in here. I will press run. Okay, I think this time it should work. I don't know why it doesn't work. Okay, let me see what happened again. Let me download again here. Okay, download again, and I'm gonna play it, and go to I think here. Okay, okay, I need to download again. Sorry. And go to safety over here. Let me go to run mode and go to reset it. Great. Now see, it's in run mode. I'm sorry that I make so many mistakes in this tutorial. And now it's in run mode, and the input signal is turned on. So we can go to here. Here is the PSI. Now it's online, and you see safety FSoE address 62 and safety output series turning on. So in this case, you can see 62 in series turning on. And then I will try to turn on I reset my e-stop I go to plus this one and reset. Done, you see. Then the 61 FSoE slave address 61 in 0 is turning on, and then I'll feedback a out 0, output 0 of the 61 FSoE address back to Pilz. And here you can see this one is a signal come from EL6910. Okay, sorry, I make some mistake in my tutorial, and now it works. And if you have any problem or if you want to discuss with me anything, please feel free to comment, to leave your comment, and or email to me or text to me in any way. And if you think this video is useful for you, please like it and share it. And I hope I can see you next time. So please have a good day. Bye bye.